All right, good morning, and today we are going to continue talking about how we can tell if triangles are congruent. So, on the top part, we're going to focus on SSS and SAS. Remember, S stands for side, A stands for angle. Okay, so if we look at this first one, this has 3 marks, this has 3 marks, so those sides match up. This side and this side match up, this side and this side match up. So, SSS. There are 3 sides marked on each, so side, side, side. Now, number 2, right now there are 2 sides matched up, so we either need to find another side or another angle. And lots of you will probably look at this and think PF and GS have to be congruent. And they do appear to be the same, but there's no way we can prove that. However, if we look in here, angle PTF and angle GTS, we can prove those are congruent because they are vertical angles, and vertical angles are always congruent. So at this point then, if we trace it, there's a side, an angle, and a side, SAS. Number 3, right now we have 2 sides marked, 1 and 2. This third side we can mark because KO is shared in both triangles. Anytime it is shared in both triangles, we know it is congruent by our reflexive property, okay? So the reflexive property tells us it's congruent. At this point now, I have SSS. If you're having trouble thinking about that, think if I covered up this triangle and just measured the top one, this would have a certain length. If I measure the bottom triangle, then that length is going to be exactly the same for KO. Okay, so reflexive SSS is what we will have then. Okay, on number 4, we don't actually have to add anything. We already have enough information. There's a side, an angle, and a side. So SAS. On number 5, we have 3 sides marked, so SSS. Number 6, right now there's not enough information, but we can add some. There's a side and there's an angle. The other side we can add right here, EF, is a part of both triangles. If it's part of both triangles, it is congruent by the reflexive property. And at this point now, I have SAS. All right, number 7. On this one, we have an arc here, so that's an angle. Now, NR is shared by both, so I can put a mark there. That's a side. But that is all I can mark. So one angle and one side, that is not enough information. I need 3 pieces of information. I only have 2. So NEI. On number 8, we've got a side, an angle, and a side. Okay, number 9. This one maybe is a little confusing. 2 sides and an angle, but the angle is not included in them. So it's ASS. Anytime we get that, ASS, remember we talked about yesterday why that does not work. There are 2 possibilities of what it could be. This does not prove anything. So it is not enough information. And there's no way we can mark anything else because there's no shared sides, there's no vertical angles, no parallel lines, nothing that can prove these are the same. Okay, now in this next section, once again, doing the same thing. So we look, there's 3 sides marked, side, side, side. So that will go right here, by side, side, side. We know they're congruent. Okay, now triangle JKL is congruent to triangle. So on this one, we need to be careful. JK, so from J to K, is 1 mark. So we know it has to involve the X and the Y in some way. So JKL, it goes over 1 and then over 2. So over 1 and then 2. So X, Y, Z. All right, our next one. If we look here, there's a side, an angle, and a side. So SAS, RPQ, right here, RPQ. We know without a doubt P has to match up with D because they both have 1 arc. So RPQ, RP is over 2, then PQ is over 1. So that one in our case will be FDE. All right. So on to the next one. Now we have 2 more congruence theorems. If we look here, the other 2 we haven't talked about yet would be ASA and AAS. So one of these for each of these. If we look, it determines is the side in between the angles or not. So on this one, the angle, the side is in between those angles. So that's ASA. And then on the final one, AAS. The side is not between the angles. So AAS. Now, JKL. So if we look, JKL, K and L are pretty easy. K has one arc, so it'll go with M. L has two marks, so it'll go with itself with L. Meanwhile, J and P are not marked, so this will be triangle PML. And our final one then, angle DHE. D has one arc, so that goes with G. H does not have an arc, so it'll have to go with F. E matches with E. So it'll be GFE. All right. So we move on down. We got 4 more we're going to look at. Okay, so these can be any of these: SSS, SAS, ASA, or AAS. So triangle DAM, and we know this one, this is an angle, this is an angle, this is a side. So AAS, if we look, D is one arc, so that will match up with C. So triangle C. A is the right angle, that will match up with the right angle B. And M will match up with M. All right, number 6. Right here we got a side, an angle, and a side. So that's our reason. And CAB. CA is 2 marks, AB is 1. So CAB goes from 2 to 1, so FED, 2 to 1. On to our next one. ABC. Triangle ABC is congruent to this triangle by SSS. There's 3 sides marked, so I put SSS, and we know it's triangle ABC. Now, SSS is easiest to see, 3 sides, but it's also maybe the hardest to write the triangle congruence. So let's be careful here. ABC. So it's over 1, then over 3. So in our case, over 1 and then over 3. EFD, over 1 and then over 3. Now our last one, number 8, right here. We have an angle, a side, and an angle. So ASA. And if we look here, it was ECD, which will have to match up with EAB. Now, this is kind of confusing, so if you are not understanding, when you get back, work with me. We can talk about this. We want to make sure we're understanding everything. The key thing to clarify is it a side or is it an angle, and that determines is it S or A, and then figure out what pattern you have. Okay. Now, these last 6 were an exit ticket in class. If you were not in class, maybe try them on your own. Okay, all I need is SSS, SAS, ASA, or AAS. Tell me which one it is. So pause the video. You could email me 9, 10, 11, 12, 13, and 14. I'll give you points for it. Hope you have a great day, and I'll see you guys soon. Bye.